or you can drop your question in the chat box. So basically the main thing, or the main first electronic device, is the diode, semiconductor diode. How the diode is generated, today we'll discuss that. So before going to the diode creation or the formation of diode, one thing is very important. One thing is very important in the silicon. In the silicon structure, how the free electron is generated, or the free electron is generated. Remember, the free electron can be generated in two ways. The last class we have shown you how just adding a doping, pentavalent doping, adding antimony, and it donates the free electron. It donates the free electron in the structure. That was one structure. That is called doping process. That is called doping process. External process. But one more process is there to get free electron. If you remember, this is the energy diagram, energy band diagram. I have discussed this type of diagram in the very first class. So in the intrinsic silicon, that means pure silicon, there are two types of silicon. One is intrinsic, one is extrinsic. So in the intrinsic silicon, at the room temperature, we know what is the basic room temperature, probably 25 degrees Celsius to 27 degrees Celsius. Okay, so in the room temperature at intrinsic silicon, room temperature means 27 degrees Celsius. Okay, that's a certain amount of heat. So at that certain amount of heat, it has sufficient heat energy. When this heat energy is applied to the silicon, suppose here you can see this diagram. Okay, is applied here, this heat energy, absorbing this heat energy, this covalent bond is broken. Okay, is broken. So when it is broken, that means one free electron is created. So when the free electron is moving from this covalent bond, you see that this is the free electron movement, but one hole is also created. So that's how the electron and hole pairs are created at room temperature. Okay, this is one of the internal process. The external process is the doping process we discussed in the last class. Okay, the internal process is at the room temperature. At the room temperature, that is 27 degrees Celsius to 25 degrees Celsius. At room temperature, when this heat goes to the silicon atom, the two silicon atoms, as their covalent bond, we all know that the covalent bond is not so strong bond. Okay, weak bond. So the covalent bond absorbs this heat energy, and one electron of this covalent bond just go outside, becomes a free electron, and one free electron and hole generated. This is hole and electron hole pair is generated. How? We can also see from the band diagram. Okay, if you have any question, please drop me the questions in the chat box. I will discuss one by one, no problem. I will discuss one by one. And also give your role and batch in the chat box. If you are newly joined, please give your role and batch in the chat box, please. Okay, so in the band diagram, we can also see that, suppose this is valence band. We all know that the valence band, the conduction band are probably empty at first in the semiconductor. We know that this is the band gap we already discussed in the first slide. So when it absorbs the heat energy, the electron was at first in the valence band, this two electron. You see that this two electron has at the valence band. So when it absorbs the heat energy, it takes those heat energy and jumps to the conduction band. So this two electron is now free electron or conduction electron. So it created two free electron by absorbing heat energy, but still it also created hole. You see that also created hole. So remember, always remember, in p-type material or in n-type material, we all know that in p-type material, holes are charge carrier. In n-type material, the electron are charge carriers, but still that is the doping process. That is one process. Other process also creates electron and hole. So that means in both p material or n type material, we have both hole and electron. How much we'll discuss later, but remember, by external process, the n-type material creates electron, but the internal process, n-type material creates both electron and hole. So definitely, in these two processes, in the n-type material, electrons are created twice and holes are created once. In the p-type material, from the two process, one is doping, one is internal, room temperature heat, absorbing heat. The holes are created twice, electron are created one time. So from this difference between holes and electrons in the semiconductor, yeah, we discussed. Let me come to the Muhammad Ali. Yes, I'm the stopping share. The two question has come. I'm just unmuting all. Yeah, one first question was Muhammad Ali. Muhammad Ali, can you listen me?
Yes, sir.
Please everybody. Okay, I'm muting all and just unmuting that particular person. Muhammad Ali, can you listen me?
Yes, sir.
Okay, your question was difference between hole and electrons in the semiconductor. We have discussed what is electron, what is hole. We have discussed, isn't it, in the last class? Hole, the
Yes.
electron was, the electron charge. What is hole? Hole was just the missing of electron. That is a void space. Before the class, I have also discussed that a hole is nothing but, a void space. In the boron structure, there are 3 electrons, should be 4 to create. So that is one void electron. There is no electron in that space. That is called a hole. Okay, hole is a void space where one electron is missing. So electron is a negative charge. So when the electron is missing, that means that space, that hole is a positive charge. I hope you got your answer.
Yes, sir.
Okay. Next, the question was from Amir. I'm unmuting Amir. Where is Amir? I cannot find. Amir, are you here? Yeah, I saw him. Amir, good morning.
Yes, sir. Good morning, sir. How are you?
Okay, nice to see you. Your question was,
Thank
since valence band electron moves, why other 3 electron doesn't move, dear sir? Okay, that's a very nice question. You're just talking about the band diagram, isn't it? I just showed it.
yes, sir.
Okay. The interesting thing is that in the band diagram I discussed in the very first class, in the conductor, the both band, conduction band and valence band are very near. So with the absorbance of small energy, they can jump easily. All the electron can jump. That's why it is conductor. So all the electrons are becoming free electron after getting those small energy. But in the semiconductor, there is a band gap. You see that there is a small white space between the two bands.
Exactly.
Yes, that value differs from material to material. Probably silicon for 1.1 electron volt, something like that. So the small room temperature energy, that is 27 degrees Celsius, if we convert it into Kelvin, that is 300 Kelvin. Okay, so from that small energy, it was just a demonstration. It's not like that only 2 electrons, only 3 electrons. It was just demonstration. The main theme was small amount of electron are created from this absorbance. So all the electrons are not taking all the energy, because the energy is also related, limited. So the amount of energy that is available, those energies absorbed only few electrons, and with the absorbance of the energy, they jump. No, they jump. So
Exactly.
all the energy that is available, which is not adequate for all electrons. That's why.
Yeah.
I think you are clear.
But I was yes, I got it.
Okay,
But
okay,
I
nice.
was confused why other three
No,
electrons
no, no.
doesn't move.
It's not. Is that
Yeah.
because there is a band gap? There is a band gap. Band gap means energy. The band diagram, the higher the go, it goes higher. It requires energy. When you have high
Exactly.
energy, it will go to the high band. When you are losing
Exactly.
energy, you will go to the lower band. I think you understand. So
Yes, sir. Thank
we're
you.
back with the slide
Please,
also.
sir.
Please
Okay.
definitely,
Thank you, sir.
Muhammad Ali. Okay, definitely ask the question. Muhammad Ali asks that, so is there an equal number of holes in valence band created? Yes. Yes. The amount of electron created in the or jumped in the conduction band, the equal number of hole created in the valence band. Because the hole, what is hole? Hole is a space. Hole is a void space. How the hole created? When the electron moves or there is no electron which was supposed to be here, which was supposed to be on that space, when it is not there, that is hole. So yeah, there is an equal number of hole in the valence band, the equal number of electron in the conduction band. So both the numbers same. So as was uh, we continue our slides. I think you got your question. Please drop your question, no problem. I will answer. I will answer as much as possible. I will answer. Okay. So yeah, the same amount of, you see that same amount of hole and same amount of electron. So so from that concept, we can see that we can say, or we will say, there are two carriers. There are two carriers in every type material, both N-type material and P-type material. So what are those? So those are majority carrier and minority carrier. Majority means bulk amount of, or minority means small amount. Majority means huge amount or large amount, or 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 uh, the the minority carrier means small amount. Okay. So in the N-type material, we discussed there are two process. One is doping process, one is internal thermal process. Okay. So in the internal process, both holes and electrons generated. But in doping process, only electrons generated. So electrons are generated twice. Okay, that's why in the N-type material, the electrons are known as majority carrier. I think you understand, because the amount is among those electron and hole, the amount is bigger for electrons. So that's why it is major. In a country where the people are, suppose in Bangladesh, the Muslim, it is a Muslim based country, because the Muslim peoples are much more. So that's why they are major people. And some of the minor peoples, I'm not considering that. Please don't consider. I'm just taking as an example. Hinduism, the Judaism, or Christianity. Those are, it's very small amount of people. That's why they are minor people in a country in terms of religion. Similarly, in India, you see that Hinduism is a very big, a very small number of Muslim. Similarly, uh, uh, in the USA, the large amount of Christianity. So Christianity is the majority there. So that the thing I'm going to tell that, so in the N-type material, as the electrons are created in the two process, so that's why it is known as majority carrier. You see that? So you see that there is the electrons are just denoted as majority carrier. But still, holes are created in the thermal process. That's why there are small amount of hole, but still it is available in the N-type carrier, N-type material. So holes are minority carrier. And also I discussed in the N-type material, there are pentavalent bonding, pentavalent doping. So those antimony donating electron. So that's why when they're donating electron, suppose you have negative charge, when you are leaving the negative charge, so you become positive. So that's why these antimony are known as donor ions and represented as plus. Represented as plus. You see that the big plus, these are donor ions. Sir, why is there these are plus sign? Because this donates electron to the structure. That's why it becomes positive. When you are leaving electron, that means you are becoming positive. So what I'm trying to say, there are two carriers, two types of carrier. One is major carrier, one is minority carriers. So major carriers in the n-type materials are electron, and the minority carrier in the n-type material is hole. Okay, so we go to the p-type material. It will be the inverse, totally opposite. We know that in the p-type material, in the doping process, it creates hole, and in the thermal process, it creates electron and hole. So hole are basically created twice. So that's why hole will be much more. In the p-type material, there will be hole much more. Okay, so that's why you see that the holes are denoted as majority carrier, and there are still electrons which are created by the thermal process at the room temperature. That is also denoted as minority carriers. Okay, and in the doping process, we use boron, indium, gallium, something like that, which has 3 electron. So basically they are short of electron, so they will take electron. When they will take electron, so they will be negative, you know. That's why these signs are negative. So these are acceptor ions because they will accept electron. Okay, so that's why these are negative signs. I think you understand what is majority carrier, what is minority carriers. I'm just, you know, going to the stopping the share and going to all and asking you about this, because these two concepts is a very important concept. Very important concept. I'm unmuting all my students. The concept is clear. Please inform me, because very it's a very,
medical certificate for medical certificate.
is it the clear? The majority carrier, the minority carrier. Okay, all are unmuted.
Okay.
Muhammad Ali, can you listen me?
Yes, sir.
Okay. So you have questions, sir. How the minority carriers are produced? I said you the very first slide in the room temperature. Okay, taking the heat energy, and the electron jumps. So electrons are created, free electron, and holes are created. That's how the minority carriers are created. Clear? Ali, Muhammad Ali. Okay. All other students are clear.
Yes, sir.
Okay. Amir, I cannot see Amir. Yeah, I can see. Amir, clear?
Clear, clear. I got
Okay.
it.
Okay. Thanks. I have discussed in a very slow process, so you can see the video also. No problem. Okay, I'm just okay. Okay. So please, more than 20 students are present. Please give your role batch in the chat box. Please give your role and batch in the chat box. So I'm starting the screen share one more time. You know, it kills time. It kills time to go forward. Okay. So the next task is the creation of PN junction. Okay. So the creation of PN junction. So how it is created? It is nothing but just taking one p type material and taking one n type material and joining together. Okay, you see that this is one p region means p type material, and this n region means n type material. You see that the p region has much more hole. These are the holes. The white balls are holes, and a small number of electron. That's why the holes are majority carrier and the number of electrons are minority carrier. Okay. And in the n region, you can see that the negative or the sign, the minus sign are much more. That means they are representing electron, and the small amount of white ball are represented as hole. So these are minority carriers. The holes are minority carriers and the electrons are majority carriers. So when we join together, they becomes a PN junction. And a very interesting thing happens when we join together. It has huge amount of holes, it has huge amount of electrons. So I'm talking about in this junction, in this junction, region, the holes and electron combines. You see that in this junction, this electron will attract the hole because both are in the two opposite charges. So positive and negative always attracts each other. So in the hole and electron, they will combine. So this electron will flow from right to left, from N region to P region, and combine together. Okay, recombine and become neutral. So this hole, not hole, this electron will go to the P region, and this in this junction area, the hole and electron will combine. Okay, so that becomes a new region that is known as depletion region. Okay, you see that is known as depletion region. You see that uh, something like that in this depletion region. This is the junction region. In this junction region, you see that all the charge are N region and P region, but there is no charge available. In the depletion region. This plus and this minus are ion. So what ion? These plus are antimony ions, and this negative sign are something like boron ion. Those immobile ions we already discussed, the donor ion, the acceptor ions, but there is no charge available in this region. Why? Because when the P junction is formed, the N region loses free electron as they diffuse across the junction. The N region loses electron because this electron goes to this junction region, and this creates a layer of positive charge near the junction because all the borons are left alone here in this junction. As the electron moves across the junction, the P region loses hole as the electron and hole recombine. So basically, from the N region, the electron goes here and the hole comes here. So electron and holes recombine and become neutral. So basically, in this region, there is no there is no charge available. All the charge, electron and holes are available in the N region and P region. So this region are totally no charge. So this region is known as depletion region. A new region created, depletion region. Okay, so you see that these two layer of positive and negative charge form a depletion region, and we all know that, sir, positive and negative, these are two terminals. This is positive, this is negative. So it will act as a potential, just like a battery. Okay, because both has two terminal, both positive terminal and the negative terminal. So it will act as a battery. So that means it has a potential. And if we made the PN junction with silicon, the value of this potential is 0.7 volt, and the value of germanium is 0.3 volt. So it acts like a barrier potential, and this potential is known as barrier potential, because we'll see in the next slides, in the coming slides, that this potential will stop the hole and electron to come together. So this is a barrier, stopping. This creates problem for the electrons and holes for further coming and recombine. The flow of electron, it stops. That's why it is known as barrier potential. I think you're clear. The depletion regions are created because of when junctions are created. Okay, when the junctions are created, at that time the electron moves to the p region, and the p region moves to the the hole. Basically the hole moves to the depletion region, and hole and electron recombine, something like that. I'm giving a very straightforward practical example. Suppose if Bangladesh and India border is open, if Bangladesh and India border is open, you know, we all have the tendency to cross the border. We all have the tendency. So some people will think that some Bangladeshi people will think that the India is better, so they will travel to India. They will travel to India. They'll cross the border and go to the India. And some people will think that okay, Bangladesh is better, so they will try to cross the border and go to the Bangladesh. So when it creates, the two governments will then, you know, make a fence, make a gate, and stop at the border region. So there will be no people available in the border anymore, because the both India and the Bangladesh will employ their border guard army. So only army will be available, so there will be no people available in the border anymore. Okay, so you can create you can just think like that. These positive signs and negative signs are the army, and these are the people. That are no more available in the, and these are the barrier. These army are the barrier. So these people cannot move there, and in region people cannot move there, because there is a barrier available. There is a bloody army are available in the border region. I think this is the very easiest example you can take. Okay, for the, so this is the depletion region created, and the barrier potential is also created. So 0.7 is for silicon, 0.7 volt. Remember, this barrier potential is 0.7 volt for silicon. It's very important concept, or very important information, because we will discuss everything for silicon. Pardon me for 1 minute. Okay, so if you have any questions, if you a valuable question, not so many questions for, you know, just for no reasons. If you have really confusions, you can draw. Why some students are drawing red lines? Yeah, one or two students have drawn a red line, that's why. Okay, now we'll see the in the last class, in the last slides we have discussed PN junction, not the diode. Okay, only junction. Now from now on we will discuss about all about diode, or semiconductor diode. Okay, so sir, how the diode is created, what is the difference between PN junction and PN junction diode? So there is not so much difference. There is only one difference, that is the two metal contact, the P region and the N region, and the PN junction, the depletion region, is everything is there. There is only two metal contacts. One is connected with the N material, and one is connected in the P material. There are two contacts. You see that both the two terminal, there are two metal contacts are created. Okay, so this is the, you know, internal structure, but the symbol, this is the symbol. This is the 3D structure. You can see the P and N type, both are the terminals, and this is the symbol. This is the diode symbol. You see that this triangle is the P, and this, you know, a straight vertical line is the N. So this is P, this is N. You see that this is the triangle. The triangle is the P, and the vertical line is N. So this is the universal diode sign. So so now we'll discuss this diode, that as we know that, sir, already there is no available ions in the PN junction, in the junction. So how can we generate the current? Okay, because we need to generate current. So we will see three cases. One case is as there is a depletion region, there is a voltage 0.7 volt or a particular voltage. So we'll see three conditions. One is when we do not apply any voltage in this junction diode or in this diode, and when we will apply positive voltage, and when we will apply negative voltage. So basically no bias condition, okay, the forward bias condition and the reverse bias condition. This will be the topic for us. So at first, the no bias condition, that means at no bias there will be no voltage available in this two structure, no voltage available in this N and P material, only the metal contacts are connected. You see that the VD is 0, no bias. At that time what will happen? What will happen? The main results I am telling you very early, that no current will flow, the current will be 0, there will be no current flow. Why? I'm discussing, but there will be no current flow. We already discussed the majority carrier and the minority carrier. Remember, the current will produce by both carriers, both minority carriers and both majority carriers. Okay, so current will be produced both for minority carriers and majority carriers. And what about this condition? This condition, when there is no voltage available, when there is no voltage available, you see that at first from the N region and the P region, the majority carrier, the negative sign, the electron moves from here to there, the electron moves from N to P. Okay, the electron moves from N to P, so it creates a current that is known as diffusion current. The current created by the majority carrier is known as diffusion current, because majority carriers in the N is negative electron and the majority carrier P is for hole. So this electron will move to that towards the hole and it will create a current, and this current is known as diffusion current, and this current is for majority carriers. Okay, but after flowing a little amount of current, okay, after flow a little amount of current, but the interesting thing will be that the current will not flow after some small amount of current. Why? Because when the depletion region is created, now after flowing, when the depletion region is also already created, when this hole will try to move in this direction, as the hole is positive, the positive sign is already here, so this positive hole and this positive ion will repel, so it will not allow this hole to flow. Similarly, this electron will try to go to this area, and this electron, this negative ion will repel, will not allow, will act as a barrier, so there will be no available there, that will be not available. Okay, so no more majority carriers will flow. So a small amount of majority carrier will flow at first before the depletion region. That current is known as diffusion current. So this is for majority carriers. So sir, what about minority carriers? You know that the minority carriers in the P type is electron, the minority carrier of the N type is hole. You know, so a very small amount of hole and very small amount of electron. But right now, when the depletion region is created, still this electron and there is a positive ion, so it will attract, okay, and this hole and this negative ion, this hole is positive, this negative ion is negative, so it will also attract, so basically this ion, this negative electron will flow from P region to N region, so there will be a small amount of current flowing. Okay, a small amount of current flowing, so that current is known as drift current. So interesting thing is that if I'm going to the next slide, you see that the region that covered positive and negative ion is called depletion region. We already discussed. The majority carrier, which is electron for n type and hole for p type, will create the current name as diffusion current. We already discussed. The minority carrier, hole for n type and electron for p type, will create the current named drift current or reverse saturation current. So basically the minority carrier will create a current and the majority carrier will also create a current. But interesting thing is that the current majority carriers creates, it will be one direction, and the minority carrier creates, it will be on opposite direction. You see that in the steady state condition these two current are equal and both are in opposite direction. If both are in opposite direction, so the net current will be zero. So you see that in the absence of applied bias, that means as there is no voltage applied in the semiconductor, that's why the net flow of charge in the one direction is zero. So the under no bias condition the current is zero. This line I have already told at the very first, that there will be no current which will be available in the no biased condition. So I think you understand. I'm just going for 1 minute for to all of you, just stopping share, just getting you the feedback. What about the feedback? My students, have you understood the process? Everyone is
For me, I got it.
yes, everyone is unmuted. Everyone is unmuted.
one-to-one.
Interesting thing is
Yes,
that
এটা এখন কি করবো বলো দেখি?
if you miss a particular one line throughout the whole conversation, you will lose the concentration. It's all about process. Okay, I am telling from the very beginning to last. So I will also upload this video, no problem, but still if you have a problem you can ask. But I think that it's not a big thing. But what I'm trying to say that when we just create two p type material and n type material together, in the junction there is a depletion region created. I give an example for the border of army, something like that. So if I don't apply any voltage, there'll be no current flow. There is a current flow internally, there is a current flow, but interesting thing is that the amount of current flow from n region to p region and p region to n region are same. Okay, both are in opposite direction, so same amount of current flow. So something like that. If I go to the border example, suppose 500 Bangladeshi people have moved to India and 500 Bangladesh Indian people moved to Bangladesh, so the net population will be same. Okay, no change, so net population will be same. So that's why when we do not give any bias voltage, bias means external voltage to the PN junction, there will be no current. So without voltage there will be no current. I think you understand. If you don't understand, please, when I upload the video, watch that video. Okay, study the slides, you will definitely understand, because I have given a very slow explanation, very step by step explanation for your better understanding, because these are the very basic. When the foundation will be not good, you will not, you cannot understand the later. We can do several mathematics, but when you don't have the proper understanding of how this works, you will not understand. Okay, that's why I'm taking much time in these slides. Every slides I'm discussing, talking about more, because for your better understanding. I think you understand my condition. Oh, okay,
Okay.
I'm just continuing one more time. Please, if you are new in the class, please drop your role and batch in the chat box. Okay, I'm remembering frequently, sorry for that. Okay, now we'll move forward very frequently, no problem, because we have already got our basics. So what is the basic difference between a forward bias and reverse bias in the direction applying? Sir, we will discuss. Muhammad Ali, don't be excited. We will discuss. We are just started our discussions. We will discuss forward bias and reverse bias. Don't worry, you will get your answer soon. Okay, so what about forward bias? So forward bias is nothing, basically connecting the voltage, the potential, the positive terminal to the p-type material terminal and the negative terminal to the n-type terminal. Okay, the p-type terminal with the positive and the n-type terminal with the negative. So what happens that you see that uh, you see this is positive sign, this is also positive sign connected with the p-type. So this positive sign, the voltage positive sign is connected with the p-type. So this is positive. Okay, so the holes are also positive, you know that this positive, so it will repel. So this positive sign will, or this positive terminal of voltage will give pressure to the hole because it will repel, so from this positive pressure, positive voltage pressure, this hole will move towards this direction, towards the right direction. So this hole will move from there to here. Similarly, the n-type material is connected with the negative terminal. So this negative will repel the electron. This negative will repel the electron. Okay. So now this electron will move from right to left. So now you see that the electron is giving pressure from this to that, and the hole is giving pressure from left to right. So now this depletion region will become thinner. The width of this depletion region will become thinner. So as much we increase the voltage, so this depletion region, this barrier will be, you know, thinner, will be less. So after a certain amount of voltage, I discussed at the very earlier, this barrier potential for silicon is 0.7 volt. So when this VD equals to 7.7 volt, 0.7 volt, there will be no depletion region available because it will give so much pressure to the hole to move from left to right, and the electron from move to right to left. So it will again recombine, and the electron will flow from N to P. So the electron flow will from N to P, and we know that, sir, the direction of current is the opposite of electron flow. So electron flow is moving from right to left, that means N to P. So the current will be from P to N. You see that, that's why the current will be the P to N, this direction. So from, you see that the ID is, the diode current is something like that in this direction, the clockwise direction. That's why as this hole and electron are majority carrier, so you see that this is the majority current, the current for the majority carrier. And we know that the majority carrier are bigger, so the current will be also bigger. So what about minority carriers? The minority carrier will also flow because there is no depletion region, so minority carrier will also flow. So this electron, you see that this two electron, small electron, this electron will also flow from P to N. So the current will be from N to P. Okay, current will be N to P. So you see that this is for minority current. So N to P is from this direction. So minority carriers are small, majority carriers are big. So the current will be, majority carrier will be big, the minority carriers will be less. So the difference will be the main diode current. You see that the ID equals to I majority minus I small, that means minority current. So this difference will be the diode current, and when this voltage VD equals to 0.7 volt for electron, the current will flow from P to N. So that is the forward biased condition. You see that. So when we are connecting positive sign with the P and the negative sign with the N, at that time, that is called forward bias. That means the current will flow within the diode. You see that the positive with the P and the negative with the N, and this is the diode. Similarly, the current will flow and the current value will be ID. You see that the expression is given here as the forward bias established by applying the positive terminal potential to the P type and the negative to the N type. The application of forward bias potential will pressure electron in the N type and the hole in the P type, and so the reduce the width of the depletion region. I said that the depletion region will be less. So after 0.7 volt there will be no depletion region, there will be no barrier potential, so the flow will be there. As the applied bias increases, the depletion region will continue to decrease in width until a flood of electron can pass through the junction, resulting a exponential rise in the current. So when the bias voltage or the forward voltage or the applied voltage is applied voltage is applied 0.7, so there will be the huge amount of current, that is called exponential rise of current. We'll see the characteristics curves. We'll definitely. The Muhammad Ali again questions that, sir, how current flow takes place in a PN junction? That was the thing I discussed just now. Okay, one more time. When we connect the positive sign in the P terminal and the negative sign in the N terminal, this positive will repel or the pressure the hole to move this direction, to move from left to right direction. So, okay, and this negative terminal will pressurize the electron to move from right to left. So all the pressures from in the middle, so this depletion region will be thinner as we increase the voltage. When it will be thinner, so there will be no barrier, so this electron, the majority electron will flow from N to P, so the current will be in the reverse direction. That's why I majority. And similarly for minority carriers, you see that this minority carriers in the P material, in the P type material, so this will also flow from P to N, so the current will be the reverse direction. So in the reverse direction the current, so the net, as the majority carriers are much more, so the current is also bigger, so that's why the difference will be a bigger difference, will be the value. There will be no zero, just like no bias voltage, so there will be a current which will be flowing in the majority current direction. You see that the current will flow in this clockwise direction. That's how the current generates in the forward bias. I think you understand. So in the reverse bias, it will be it will recur only 2 times. It's just the inverse, the negative in the P type contact and the positive sign in the N type contact. So negative in the P contact, positive in the N contact. So this is negative, so hole is positive, so it will attract hole. So now the hole will come in the terminal, all the holes will come in the terminal. Similarly, it is positive sign and all the electrons are negative, so it will attract the electrons, so all the electrons will come in the terminal. So this depletion region will be much more bigger because there will be no holes and electrons will be available, so this depletion region will be much more bigger, so there will be no current, for the majority carrier. Sir, what about minority carriers? The electrons are in the minority carriers, because this is negative, this will not repel, so this small amount of electron will flow to the N, so there will be a small amount of electron flow from P to N, a small amount of current will also flow from N to P. So a very small amount of current, which is very negligible, very small, a very small amount of current flow, but the main current flow will be for the majority current, that will be 0. So when the diode in the reversed bias, that means P in the negative and N in the positive, similar, just like that, the negative voltage in the P side and the positive voltage in the N side, there will be no current flow. There will be no current flow, where very small negative current will be flow, which is quite negligible in real life, a very small, that is for the minority currents. So that's why for no bias, when the VD equals to 0, there will be no current. For positive voltage, VD equals to positive, the current will flow, and the reverse bias also the current will not flow. So from these findings, we'll go to all the descriptions are given here. We'll go to the diode characteristics curves. Okay, how the diode operates. So from that three conditions, we can now come to the point at zero. That means zero means this is the voltage applied, this is the current. Okay, at zero, there is, you see that there is no voltage, there is no current at zero. But at forward bias means you are giving forward positive voltage. You see that when the zero applied voltage zero becomes positive at 0.7 volt, you see that huge amount of exponential rise, huge current flow, an exponential rise, a huge current flow happens. Okay, this is called forward bias. But when the negative voltage, you know, in this side, you know, all know that the graphically representation, when the negative voltage is applied from 0 to minus sign, you see that a very small amount of current is flowing, but there is, which is quite negligible, a very small amount of current. And this is the another condition which we'll discuss later, which is special type of diode is created from this condition. The breakdown voltage we'll discuss later. But from these VI characteristics curves or IV characteristics curve, we can see that the forward bias condition, the no bias at zero, and the reverse bias condition. So that was the thing. These are the questions. Thank you for today's class. If you have questions, you can ask. But I think that the explanation was quite enough. But still, you have questions, you can ask, no problem. And but I want to end the class very soon, so I'm stopping the screen share and coming to the the students. Please give your role. If you are available, please give your role. Please give your role. Please give your role. If you're okay, I'm unmuting all. Probably everyone is muted. Everyone is unmuted. Okay, the class lecture was very important. The overall class lecture was very important. I tried my best to explain. I think that you have understood. But still, if you don't understand, I will give you the slides. I will give you the slides now. You see one more time. Okay, I will upload the class lecture within 1 or 2 hours. You listen the class lecture one more time. The explanation was, everything is given. Okay, so if you have still faced the problem, we can discuss this in the next class, in the beginning of the next class. Okay. Okay, because I have one more class. I want to record. I have to record this. I didn't do my breakfast, and that's why, you know. And more than 1 hour, it gives time. It gives really pain for any teacher. You know, brain headaches creates problem. So I don't want to create any kind of boredom. No problem. You see the lecture. You listen the video lecture one more time. I think you'll be understand. But still, there is a problem. I will you know, answer in the next class. No problem. Please give your roll number in the chat box. Everyone, please give your roll number before ending. Give your roll number in the chat box. Everyone, if you do not did. And how many students we have in this batch? 26. 26 students. Okay, nice. I think everyone has given the roll number. I want to end this class here. I think you have okay, everyone is giving the roll number. No problem. I think it was done. So be safe. See you in the next class. In the Thursday, we have one more class. So I think the class will be very effective. So try to attend the class just like us. Okay. So that's it for today. Be safe. Be safe. And I'm giving you the, what can I say? I'm giving you the class lecture after this class. No problem. So I'm ending this video here. Okay, be
Okay,
safe.
sir. Thank you.
Assalamu alaikum to all.
Okay, thank you.
Have a good day.